Hey everyone, I'm Brian Cantrell, co-founder and CTO of Oxide. Great to be with you this morning. Thanks for joining us. It's a fun space to be in because we're actually making real stuff, right? And as Steve outlined, we took a real, in this case, literal clean sheet of paper. This was not a napkin, but it was damn close. This is an actual sheet of paper. And when we started the company, we had been confined by the state of the industry, which had become commoditized, had become ossified, with different companies all delivering these different layers of the stack. And when you tried to get them to work together, you, the customer, were often the one who was performing that integration. And you've got fingers pointing at one another. I mean, and honestly, in many cases, you would have vendors blaming one another. And the actual uncomfortable truth is they're often both right. They are often actually, the problem is not crisply with one vendor or another. It's actually at that integration point, and where it's like, actually, your behavior is reasonable taken on its own, and you, other vendor, your behavior is actually reasonable taken on its own, if you need me as your customer to tell you that. But when I combine them, I have a pathological, unusable system, and you are treating me like it's my fault. And you're the only customer seeing this. Yeah. And the number of times that if you've been a large customer, it's extremely frustrating to hear. And you will never hear that out of Oxide. You will hear that we have never seen this before, though. Because it feels like it's an excuse. You're the only customer seeing this. Feels like an excuse to not investigate your problem. We started with a clean sheet of paper. And we knew that with a clean sheet of paper, we were going to be solving a bunch of problems. All of these problems had accrued over decades in this industry, going back literally to the dawn of the PC, because we were trying to run personal computers in our data centers. We, enterprise users, hyperscalers weren't doing that. Hyperscalers had long since figured out that this doesn't work. They had designed their own machines. Their own machines fit for purpose. They kind of, befitting each of them, they kind of acted with their own idiosyncrasies. Google built their own and then wrote a book explaining how awesome it was, the warehouse-sized computer. So you can read a book and appreciate Google's brilliance. You're like, do I get to buy one? He's like, no. But look, you can admire my great work here. You're like, okay, Google, yes, it's great. It's amazing, terrific. Amazon, you could rent it, right? Amazon was very closed-lipped about what they'd done, but you could rent it. You could not buy it. Facebook, now Meta, interestingly enough, kind of did the most interesting motion where the technologists inside of Facebook said, this is kind of not right. That we developed this great innovation that the world doesn't actually have, and they started the Open Compute Project as an initiative to share those innovations. So you could actually go, as Steve and I did, to OCP Summit as we were contemplating Oxide. We went to OCP Summit, and you look at these machines, and like, this doesn't look anything like the machines that I have to run, these commodity servers. This looks like, why don't I get to have these? And it's really basic. It starts, but certainly does not end, with the physicality of the system. The first thing you notice on these systems is they've got a DC bus bar based design. So you've got a power shelf that rectifies from AC to DC, and you run direct current, DC, up and down the spine of the machine. And those sleds, blind made in to that direct current, means there's no AC power supply per 1U, 2U. And once you see this, you can't unsee it. Once you are aware of this and aware that literally every hyperscaler, Microsoft, Meta, Google, Amazon, all run with a DC bus bar based design. This is not like new thinking. This comes out of the telco world. This happened for a long time. Anyone running at scale runs with a DC based bus bar. Not enterprise computing. Enterprise computing has got AC power supplies per 1U, per 2U. It's cords everywhere. It's fans everywhere. It's heat everywhere. It's inefficiency. And that is the beginning. That is the most visceral thing we were seeking to disrupt, but we knew we were going to be, when you take a clean sheet of paper, when you take this thing, there are a whole bunch of things that we knew we would be able to go do. Yes, be able to do what the hyperscalers have done. We also knew we were going to be able to leapfrog the hyperscalers and develop yet new differentiators. Give you a very concrete example of that. We assumed, if you looked at the Open Compute project, you looked at like that Tioga Pass circa 2019, DC power in the back, networking cables out the front. We assumed we were going to do the same thing. You look at a picture from Google when they're flexing on you. They're providing you those pictures of their DCs, and it's all like lovely pastel-colored cables, but it's cabling coming out the front. That's what we assumed we were going to go do. But we had the luxury of a clean sheet of paper. With that clean sheet of paper, we actually had more latitude. We were actually talking to a connectivity vendor, and they're like, out of curiosity, why are you guys doing the cabling out the front? We're like, because everyone does it that way? I mean, the hyperscalers do it that way. It's like, yeah, the hyperscalers do it that way, but not if they were taking a clean sheet of paper today, they wouldn't. What would they do? They would blind mate into a cabled backplane. Cable the backplane, blind mate the network connector in. Like, can we do that? Like, oh, absolutely, you can do that. Why don't they do it? Well, they're afraid to do it. And that of course, is like catnip. Like, oh, they're afraid to do it. Okay, we've got to go do that then. That's great. That cable backplane was a bet the company moment. It has removed the cabling from the system. You take a sled, there is no cabling in that sled. The backplane is cabled, that sled goes in, locks in, no cabling. Because where there's cabling, there's miscabling. That was, again, it was the beginning. Another bet the company moment. There is no bias in the system. BIOS, the basic input-output system. This is an idea, all caps, must be screamed. This comes from CPM. CPM predates DOS. DOS is from my childhood. As my children are quick to remind me, I'm old. This has been around for a really, really long time. The bias is this lowest layer of platform enablement that initializes the computer, before the actual operating system runs. Everybody on x86, and sadly many people on ARM, run with a bias, with a UEFI bias. We knew that thing was a huge problem, wanted to rip it out, wanted to do our own low-level platform enablement. This was something that AMD thought to be impossible. Why? Because Google had tried and failed. If Google has tried and failed, it must be tautologically impossible. And it was really, really hard, and it was another bet the company moment. We got it working. We don't have a bias in our system. We boot holistically. First instruction is our instruction. We do all that low-level platform enablement and initialization and bring up the entire stack in front of it, on top of it, including all of the distributed system, the control plane on top of it. There are a lot of these. When we had a clean sheet of paper, we had a lot of opportunity to do things that people hadn't done. For each of the things that we did, was not hard to find technologists to say, yeah, of course this is the way you would do it if you got a clean sheet of paper, but you never get a clean sheet of paper. We got a clean sheet of paper. We didn't want to spoil it. What this meant is it's a little hard to be crisp about the differentiator of Oxide. What is the differentiator of Oxide? It's like, well, it's complicated. And we had a board member, the great Pierre Lamont. If you don't know Pierre, Pierre is a truly singular individual. Pierre was at Fairchild back in the day. Pierre hired Andy Grove at Fairchild. So yes, Pierre just celebrated his 95th birthday. We are the last company that Pierre helped found. Pierre was on our founding board. I would like to say that we are the last of the Fair children. If you know, they had this idea in the 60s and 70s of companies that were spun out of Fairchild. Oxide is the last of the Fair children. Pierre's great. Pierre is infamously tough. And Pierre says to me, we've had many direct conversations. Pierre says to me, what is the differentiator for Oxide? I'm like, well, it's complicated. Now, that's actually what I wanted to say. In maybe the first or second board meeting, Pierre had banned my use of the word complicated. Didn't want to hear it's complicated. So I had to use all these euphemisms for like, well, it's nuanced, it's multifaceted. I'm like, well, Pierre, I know this is not what you want to hear, but there's not one differentiator. There are a bunch of different differentiators, and it depends on what your biggest problem is. We have absolutely differentiated on power and efficiency. We've differentiated on reliability, on operability, for sure. We've differentiated, just as Steve was talking about the time to deployment. That was a lodestar for us. We want that rack to arrive. We want it to come out of the crate. Importantly, sleds shipping the crate. We want that thing to be spun up and have developers on that thing in hours, not days, weeks, months. So there are many different differentiators. And that's what you get when you get a clean sheet of paper. That's the good news, right? Well, okay, what vertical are you targeting? It's complicated. It's a general purpose machine. There are a bunch of different verticals for whom this is really valuable. So part of what we honestly did not know when we started the company, we knew we were building it the way we wanted it to be built. We had experience deploying at scale at Joyent and then very much at Samsung. We knew these were pain points that existed, but you don't necessarily know the specifics of like who's gonna grab whom. And when it took us 4 years to build this thing, 3.5. It took us, and actually, I really should stick to 3.5 and not 4, because we took our first capital in 2019. We shipped in July. June is when we shipped. July is when it arrived of 2023. Excuse me. So it took about 3.5 years. The reason the 3.5 years is important is because when we first started the company, we said it was going to take 2 to 3 years to build. And Pierre, quite famously, when we were originally pitching him, said, "Which is it, 2 or 3?" And I'm like, eyeball to eyeball with him, and I'm like, 2 to 3. It's like, which is it? He's like, okay, this is like, anyway, I love Pierre. It's great. Pierre asks very direct questions and gets ambiguous answers from me and manages to still stay in the room, which is great. So it took us 3.5 years to build. When it takes you something 3.5 years to build, the world can change a lot from underneath you. And we knew that that on-prem compute was not going to go away. We felt very confident that the demand for running elastic infrastructure on-prem, we knew that was not going to go away. We knew that was going to grow over time. And that has grown over time. It's a little bit amusing to me when venture capitalists that passed on us send me these like public reports showing the growth of on-prem usage. Like, why are you sending this to me? I should be sending this to you. Like, you passed on us because you didn't think this market existed. We knew the market existed. Absolutely knew the market existed. And absolutely knew that there would be increase. There was a question earlier in Steve's session about sovereignty, data sovereignty. We knew that trend was going to continue. We knew that and especially knew that there were economic drivers. And the economic driver is still like the driver, I think. I mean, if Pierre were to really get me down to like, what is the differentiator? Ultimately, it has to be around doing more with less. But there's a lot of different ways in which that happens. So we didn't know what was going to happen necessarily. We knew that there was going to be demand for this, but it's like you just don't know. You just don't know what's going to happen. When we first started the company, one of the earliest advisors of the company is like, you've got to run ESX on this thing. It's like, bad news, that's not going to happen. We're not running ESX on this thing. Let us re-explain to you what we're doing. We are doing our own hypervisor, our own control plane, our own distributed system to provision the primitives of our system, to provision compute, storage, networking. So we are not going to run ESX on this thing. And he's like, I think you're making a huge mistake. Well, needless to say, a couple years down the road, he's like, you guys are geniuses. And like, you were so like, did you know this was going to happen? Like, well, no, not exactly. Didn't really predict the acquisition of VMware by Avago. I insist on calling them Avago because Avago has taken on the skin of Broadcom to give themselves like legitimacy. Sorry, this is private equity. The ticker is still Avago. I'm going to call them Avago. So they're just a point of principle, I guess. But we did not predict that. We did not, but with that happening, the customer pain is definitely predictable. And we've gotten a lot of people who are all of a sudden newly interested in Oxide because of that. But we didn't know exactly what was going to unfold. We also knew that there would probably be something, just like when you take a clean sheet of paper, you know that there's probably something that you're not considering, like that cabled backplane, an opportunity that you're going to have that no one else is going to have because you took a clean sheet of paper. And so we know that there's probably going to be a market that we can't really predict right now that's going to be a huge tailwind. If you look at successful companies, they have this. I mean, famously with Nutanix, this is VDI, right? I was at Sun back in the day. I was at Sun for kind of exactly the latter half of its life, was there from 96, and I went down with the ship in 2010. But if you look at Sun in the 80s, EDA, right? EDA was explosive for those workstation companies. So there was a market that they didn't necessarily predict, but it was a huge tailwind. So we thought there might be one of those markets. But I'll be candid with you that I'm surprised a little bit about what that market is and the differentiator that they really care about. So to give you a little bit of context for this, when we were first announcing the Series A, we were working, with a PR firm as one does, and they're talking to reporters as one does. They're like, this really needs to be an AI company. It's like, what do you mean this needs to be an AI company? I mean, come on. And they're like, well, what is your AI story? I'm like, we're making this general purpose computer, and AI is obviously important, and we saw that, but that's like it's the accelerators that are targeting that, clearly NVIDIA, and then a bunch of other folks. It's like, well, what's your accelerator story? We get this a lot. What are you guys doing about GPU? Okay, what are we doing about the GPU? Well, the GPU, as I tell people, there are two doors. One is labeled partner with NVIDIA, and the other is labeled compete with NVIDIA. And what they have in common, those doorknobs are both hot. There's an inferno blazing on the other side of both of those doors. Those are both very complicated doors to go through. And we've been like, you know what? We've got enough to go do on general purpose compute, networking, storage. We absolutely are keeping an eye on what we wanted to do with an accelerator-based product, but it's a bit of a gory market, and NVIDIA's executing well and so on. So it's like not really rushing to go partner with NVIDIA or compete with NVIDIA. We're happy to kind of be off to the side. All right, well, okay. They kind of throw up their hands like, well, they can't get a reporter to write about something, it's not AI. All right, fine. But then some of the big AI companies came knocking. It's like, well, okay, what's this about? And as it turns out, and again, this is like, Steve was describing having the national labs having to kick our door down. Sometimes, it's a little bit thick for you. Well, we're a little bit thick. I'm a little bit thick we try to explain to these, large AI companies that like, no, we don't have an accelerator. Yeah, we know that. So you think these models are all GPUs? Well, I guess not. So if you go to your LLM of choice, ChatGPT, what have you, you see searching the web, when you type something in, you think a GPU is searching the web? No, that's a CPU. CPU is searching the web. Mm-hmm. You think that when they're training their next gen model, someone's got to go out and crawl the web, pull that in? Think the GPU's out there crawling the web? No. You think a GPU is doing all the processing it needs to do kind of traditional map reduce like data pre-training on that? No. CPUs. You're like, oh, right. CPUs, that's what we make. They're like, yes, that's what you make. And by the way, when we look at we companies with a lot of compute, and the large model companies have a lot of compute, like I've got some bad choices. Right now, I'm in the public cloud, and it's killing me. This is economically ruinous to be in the public cloud. So I know I'm going to need to go on-prem. I'm going to need to own my own compute, especially when you look in the even not so indefinite future. I need to own my own compute. Okay. So that was, I mean, again, I'm a little embarrassed to be like, oh, right, okay, yeah, I guess that makes sense. And you realize that like all of the trends, I mean, it probably was true 2 years ago that there was much less of a CPU component. But if you look at all of the trends towards those large models around test time compute, around, whenever you are using these models, and I love it when they write a program for you, and you can have them show their work, and they're like writing a program for you, that program is executed, all that is happening on a CPU. There's a lot of CPU involved, yeah.
So kind of bouncing off of that, you guys have talked a lot about energy efficiency.
Yeah.
If you're doing something with AI and you have lots of GPUs, that's going to be, the majority of your energy usage. How much and if you're using your platform to, do these other things that you're talking about, how much does that factor in, or does it just kind of get overwhelmed by, how much compute is
Yeah, I mean, I think that, and again, it kind of depends on who you're talking to. If you're talking to like an enterprise user that's kind of pulling in some GPUs that's already power constrained, our ability, and this was actually when we were kind of talking about this in kind of the 2022, 2023 time frame, the reason they were interested is like, hey, I can actually go take my traditional rack of compute and I can now get a lot more bang for the buck. I mean, in terms of performance per watt, we are definitely a step function compared to what one would run from a kind of Dell HP Supermicro. So for those folks, yes, absolutely. For the large model folks, I think that they are, I mean, their power
Right.
is,
I guess my
yeah.
question is like, does it become substantial enough that it's like, hey, if you switch over to us for the CPU side,
Right.
can you fit in X amount more GPU?
For sure.
Like that?
And if you were to tell me, hey, with no other data, hey, the large model companies are really interested in Oxide, I would have that same, I'd be like, oh, it must be because of the power. It's like, well, yeah, sure, like the power. That's actually not what they're most interested in. And what they're most interested in did surprise me. What they're most interested in is something else that we took a clean sheet of paper on, which is the security of the system. So we put a true root of trust in the system. Really took a page from what the iPhone did with its root of trust, with what you see in like the Chromebook model. Put a true root of trust with secure silicon, with the idea of being able to test the entire stack of software. So in the kind of the PC world, part of the problem is that you've got this kind of verified boot in the BIOS, but it kind of ends there. And I actually I need to run an entire control plane on top of this. There's a whole SBOM I've got associated with that. I need to attest this whole layer of software, and then I want to pull that in to my own control plane, my own being a user of Oxide, so I know what I'm running on. I've got confidence in what I'm running on. And that is overwhelmingly what has drawn them to Oxide. And, at one point, because I felt like, it just felt like, okay, I can see why they're interested in Oxide, but, how differentiated are we really going to be? And on power, we're certainly differentiated. On power observability, we are extremely differentiated. Namely, like, we can tell you how much power is going to your fans, for example. In the Oxide rack, very little, but we can demonstrate that. You don't get that out of traditional systems. In traditional systems, you actually don't get that kind of granularity. But that's actually not what they cared about. What they cared about was that ability to do attestation of the entire stack. And what they're very concerned about, because this is like some of the most important stuff we've developed in terms of these models, they're naturally very concerned about very sophisticated attacks, about supply chain style attacks. You may remember the Bloomberg did a piece in 2018 on the implant at Supermicro. It's a very controversial story because the implant itself has never been produced. They wrote a story in 2021 reiterating their belief that the implant exists. They made the somewhat dubious decision when they ran this story in 2018 to put a picture of a finger holding a piece of electronics. I think it's like a 604 resistor, honestly. But they wanted to do that to kind of make it more realistic. It's like you've actually made it less realistic because no one knows what this implant actually is. But it stoked a lot of concerns about what would an implant look like? What would it look like to infiltrate the supply chain, especially if you look at the traditional BMC, the baseboard management controller, which also eliminated, replaced that with our own service processor and own software. That baseboard management controller is a completely proprietary piece of silicon with proprietary software coming from a source that you don't control. And if the BMC gets rooted, you control heaven and earth on the machine. So the kinds of questions that they were asking us, that these large model companies are asking us, you look through their diligence and you're like, oh, you're asking us questions about where are sources of non-volatile memory on the actual board? Because you're concerned about an attacker being able to hide out in some of the non-volatile memory on the board. Well, we can answer that question really quickly because we designed the board. We designed it from first principles. We can tell you exactly where all this stuff is. And when you're like, if this is what you care about, Oxide is going to be extremely differentiated. Because I can tell you as a Dell customer, an HP customer, a Supermicro customer, it's literally impossible to get answers to those questions. Speaking for Dell, we're a big Dell customer, like they actually don't know. They actually don't know where all the sources of non-volatility are.
Right.
Yes.
Oh, go ahead.
Yes.
No.
Okay, so I'm going to come from a business standpoint because
Sure.
a lot of what you're saying is way over my head in terms of not as smart as you, that's for sure. You talk about that there are some very specific value propositions that you bring, and there's a wide variety, and I can understand that. Can you talk about a comparable rack that you would see from Dell or somebody else versus what you have? That would be one in terms of a cost, efficiency, all those efficiency issues. Second piece to that is I hear what you're saying on the value proposition of what you're bringing in. I am sure the numbers are big, very big differentiation between a Dell rack and your rack. My fear would be a single vendor. My fear would be I'm getting back to the mini computer, the mainframe computer, et cetera.
Sure. Yeah.
That I'm tied to you in that situation, and that's dang scary. Although you're tied to a vendor no matter what.
There we go. You're answering your own question.
I'm answering that question, but so I need to go beyond. So I need to get beyond. It can't be just a 30% value proposition. It has to be bigger than that.
I mean, it depends on who you're talking to and why, but yes.
Yeah, but bigger than that. If I'm looking at how do I do the sovereign, if I have a sovereign issue, if I have an energy issue, is a completely different one. So I'll stop there, rattling, and you can answer.
Yeah, I mean, so a couple of things. One, you're absolutely right that we all put faith in single providers, right? And that has risks.
Yeah, and so get beyond. I understand that. So in order to get beyond that risk,
how do you mitigate those risks?
The number has to be significant. It's kind of like clients that I had you're talking about this morning. Clients we had over in Europe buying Huawei, and the reason why they bought Huawei is because Huawei came in and was over 30% different cost selling to them. Otherwise, I would never have they would never have been able to buy them.
Yeah, and I can assure you that Huawei, that a 30% delta in price would not make Huawei attractive to large model providers.
I do understand that.
I mean, so
understand where I'm going with this.
Yeah. I mean, so I think that there are a couple of things. One, in terms of totally get the single vendor risk. And you kind of get it's like, God, are we reinventing mini computers or are we reinventing mainframes? And we're mindful of that. I think that a big difference is that we live in an open source era. And so we get this really crisp, clean, open source revenue model. Namely, like unlike these companies that have to go, relicense themselves to figure out how to make money, we make money because you buy the thing. So what that allows us to do is be very transparent. So we uniquely have opened up all of our software. So if you are running Dell, HPE, Supermicro, you're actually beholden to a single vendor called American Megatrends, AMI. AMI is actually the vendor that's doing the proprietary layer that is common to all of those systems. There's only one company that is going to give you a machine. There's only one way to boot an x86 box without having AMI involved, and that's to run with Oxide. We give you all of that source code, uniquely. AMI is not open source. That BIOS is very proprietary.
Is that an OCP project or OCP related in any way?
Is ours an OCP project? Or is AMI is definitely not an OCP project?
No, I know.
But it's
You're open.
Okay. No, it's open source, but we haven't made it a formal OCP project, in part because we are open sourcing it for slightly different reasons.
Well, I'm just wondering if it's part of a broader community or if it's an Oxide community open source.
I mean, we have open sourced our entire stack, and at any given layer, you will find its own community. Okay. So one of the things that we did, we open sourced. We had we needed our own operating system. We needed an operating system for the microcontroller that we were going to use to replace the BMC with a service processor. We wanted to use existing open source things that were out there, but ultimately we couldn't find one that fit our goals. So we fittingly named the operating system Hubris. So Hubris is our operating system that runs on the microcontroller. The debugger, by the way, for Hubris is called Humility. And those are all open source. Those are being used in lots of interesting places. So
yeah, okay. It's a question of there's open sources in community development. There's open sources in transparency. Used to be.
And I would say that the priority is open source for transparency, but because we solve problems that people are really interested to have solved, we've had a lot of open source as community follow on from that. And it's not, on the one hand, it doesn't completely mitigate single vendor risk, but it gives people confidence that, like, okay, I can actually see this whole thing, which again, I can't get out of anybody else. Nobody else allows me that transparency. And this is at the absolute brainstem of the system. And it's so it's not a 30% kind of a thing. It is a, like, this is an existential risk versus this is a risk I can manage kind of a thing.
So
Yes.
it seems like the competitive factor for you is not the traditional OEMs, but it's more the OCP community that is building systems based
You would think.
on design.
You would think it is so, and that's actually kind of what we would have thought for sure when Steve and I went together to OCP Summit again before we started the company. We're like, let's go buy one of these racks. And you go to, like, okay, who do I need to go to buy one of these racks? And they're like, sorry, which part of Facebook are you in? Which group am I talking to? Because if you want to build an OCP, there's not a thing you buy. You got to go ODM direct. And if you got to go ODM direct, like, your numbers need to be huge because now you are doing your own Oxide. And so there's not and we would bump into other enterprise buyers who are kind of like, oh, I want to go check out this OCP thing. You're like, wait a minute, this is not, there's nothing I can buy here. Because I've got to go, like, sure, I can go talk to Quanta. I can go, like, and I can, if you want to go talk to Quanta about the kind of numbers that you need for Quanta to actually build a box with your specification. But there are not board designs coming out of OCP. They're rack designs, but not board designs. So you might think that, but it's actually much more of OCP is great. Love OCP, but it is by no means products. It is hyperscalers collaborating on how they do their vendor management.
So I get the barriers to entry for manufacturers on that side. I'm also very interested in the barriers to consumption from the customer side.
Yeah.
Sounds like you guys are going after enterprise, not necessarily MSPs, which would seem
not MSPs, yeah.
Right, which would seem to me to be a natural way to go. But I won't get into that right now. But especially with the move from public clouds to something less public. But the entry point for your product seems like a rack.
A rack.
Right?
Yep.
So, and I run into this with some other types of vendors as well. How do, like, if I'm an enterprise, getting into your product involves pretty much buying into the management model. I have to learn the APIs. I have to integrate. I have to learn your automation. Now, if I'm already a cloud savvy organization, I know a lot of this stuff. Probably very little. I'm going to imagine there's going to be very little to learn, which is great. But I still have to buy into your management plane, your management,
absolutely,
your constructs, right? That's not only an investment, but I'm putting a ring on it, right? So if I'm in, I got to be in. Because I'm not going to. The idea is I'm not just going to buy one rack. I'm going to go all in eventually, and I'm going to have racks either all in there or everywhere. And you're very happy if that happens, right? So, if I'm an enterprise, it's like you're at, if I'm first getting through the cycle, that level of commitment up front is hard to.
Yes.
It's hard to obtain. So, and of course, you're not just going to throw in. Maybe you do at this point in your world, but I want to start. You're going to throw in a rack at a large customer. Maybe you would invest in that, but not for at scale. You can't. So I see on the website you've got a trial.
So that trial is that you get to. We've got a rack in a co-location racks in a co-location facility. And we've designed multi-tenancy into the very core of the product, which we didn't do for this reason, but it ended up being a huge benefit, is that we can now spin, you want to try the Oxide rack? Great, we'll spin you up as a tenant on this colo rack. Right. You can hop in there and you can try it out.
Yeah, and I'm Glenn Decazar, I'm from Equinix, actually.
Yeah, there you go. Yeah.
I don't know if you're
well, so your question is so great that we've got an entire presentation right now that's going to address exactly this. So my colleague Matthew Sanabria is working on exactly the problem you're talking about, because this is a very important problem about how do you integrate in to the environment that people have. And this honestly would have been much harder a decade ago, But and this is, you can correct me if you disagree, but I think the momentum behind Kubernetes in 2015 was actually around people getting optionality around their cloud vendors. Just to the point earlier about having a single vendor, like people felt very trapped by AWS in 2015. Kubernetes, people lunge at because it's like, this is going to be my multi-cloud story. And so that has given us, we are now a full decade after that, we've got a lot of software substrate that we can go integrate in that makes it super easy for customers to use our product.